Hello students, this is Harish Konda. Welcome to my channel, the chemistry classroom. So, in the previous video, we discussed about criss-cross principle. So, it is the extension for that class. So, below the description is given. Please follow that first video. So, the criss-cross principle is having some limitations. That limitations, what is that one? The criss-cross principle is only for two elements. That's A, M, B, N. In this principle, the A is and B, the two are the elements. M and N are the valencies of that elements. So, the criss-cross principle is limited for only two elements. More than two elements are not able to write this formula. So today what we are doing, we are expanding the criss-cross principle. So how we are expanding? So what is the criss-cross principle? How we can write more than two elements in the compound? Now we see. So before that, A and B are the elements. Now A and B are the ions. What they are called? They are called ions. So generally we have two type of ions. The one is called cation and the second is called anion. The cation indicates the plus charged ion. The anion indicates the minus charged ion. Here the A and B, they are the opposite ions. The A is having positive charge. That means it is cation. And the B is charged negative charge and it is called anion. So, before in the criss-cross principle, A and B are the elements. Now, A and B are the ions. Then A indicates the cation and B indicates anion. So, generally if you want to write a compound, for example, you take one compound that is sodium chloride. What is the compound? It is sodium chloride. When you see this compound, the compound is having two words. It is a combination of two words. The one is sodium and the second is chloride. So here it is a combination of two words. The one is sodium and second is chloride. The sodium, the first part, it is prefix. The first part indicates the cation and second part indicates the anion in whatever the compound it is. Here we have two words. The one is cation and the second is anion. The sodium indicates the cation, chloride indicates the anion. So generally the cations, they are from the bases. The compounds, the base compounds, they give the cations and acid compounds, they give the anions. Generally, one compound if you form the sodium chloride, in the sodium chloride the sodium comes from base and chloride comes from acid. For example, you see the sodium comes from the base, it is sodium hydroxide, and the chloride comes from the acid, that is hydrochloric acid, HCl. And what you are forming, you see, it is Na plus and OH minus ion, H plus and Cl minus ion. Na plus react with Cl minus ion. What you form? NaCl plus H2O. That means here sodium chloride is formed. The sodium chloride, in the sodium chloride, Na plus ion from the sodium hydroxide. In the sodium chloride, Cl minus ion from the HCl. That means in the compound sodium chloride, the sodium comes from the base and anion Cl minus comes from the acid. So generally in the compound we have two words. The one indicates the cation, the second indicates the anion. Cations are from the bases and anions are from the acids. Very first we introduce the anions. So they are from the acids. Here we have some anions. So from the anions, how that anion is forming, now we see, here you see, some anions are listed. So some acids are listed. From the acids, I am giving the anions. So for example, here you see the first acid, hydrofluoric acid. And the second acid is hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, sulfurous acid, nitric acid, nitrous acid, phosphoric acid, phosphorus acid, carbonic acid, acetic acid, oxalic acid, like that acids we are taken. From that acids, so what the ion is formed? The anion is formed. How I am writing the anion? Now you see. Here for example, I am writing one acid, hydrofluoric acid HF. From this acid, so what you are forming? Anion is formed. So from the acid, how the anion is formed? Now you see. So in this acid, except the hydrogen, the remaining indicates the anion. Except the hydrogen, the remaining indicates the anion. So what is remaining here? F is remaining. And how many hydrogens are in that acid? Only one hydrogen. So what you get? The negative charge. Why? Because it is anion. Anion is getting negative charge. How much negative charge you form? -1. Why? Because here you have only one H plus ion. So what you are getting? 1 minus F minus 1. So from the HF acid, hydrofluoric acid, except the hydrogen, the remaining is anion. So what is the anion? It is F. And how many minus charges are in the anion? So here you have only one hydrogen, so F minus 1 you form. So one more example you take, H2SO4, sulfuric acid. So except the hydrogen, the remaining is anion. So what is the anion? It is SO4. Why? Because except the hydrogen, the remaining is SO4. So how many hydrogens here you have? 2 hydrogens. So SO4 is getting 2 minus 2 charge. Why? Because here you have 2 hydrogens. So it is getting -2. So it is SO4 -2. One more example will take acetic acid, CH3COOH. Here we have 2 hydrogens. The one is attached with the carbon. The second hydrogen is attached with the oxygen. So which hydrogen you have to take? Which is attached to the oxygen, that only you are counted. So here the hydrogen, except the hydrogen, the remaining is the anion. What is the remaining? It is CH3COO. So what is, how many hydrogens you have? Only one. So what the charge you are getting? Only one. So it is CH3CO minus. So from the acids you are getting the anions. So what is the anion from HF acid? So it is F minus 1. From H2SO4, SO4 minus 2. From acetic acid, CH3CO minus. One more example I will take, H2C2O4. It is oxalic acid. From the oxalic acid, the hydrogen, remaining hydrogen, the remaining part is anion, it is C2O4. And how many hydrogens you have? 2. So it is O minus 2. So like that you are writing C2O4 minus 2. So the anions we are formed. Now the name of the anion we have to indicate. Here you see, if the acid is with 2 elements only, you listen carefully, if the acid is with 2 elements only, in that 2 elements, one is forming the anion. That anion is called ion. What is anion? It is ion. So for example, you see HF, hydrofluoric acid, it is with only 2 elements. So one is hydrogen, second is F, and the F is formed the anion. So only one element is forming the anion. So that anion is called ion. So fluorine formed the ion. So it is called fluoride. What it is? Fluoride. Then it is chloride, bromide, iodide, oxide, nitride, phosphide. Like that, so many you have. If one element is forming minus ion, that minus ion is called ion. If it is fluorine, fluoride. If it is oxygen, it is oxide. For example, you see H2O. So except the hydrogen, remaining is anion. That anion is oxygen. How many hydrogens you have? 2 only. So it is -2. Only one element is forming the anion. So it is called oxide. So like that we are forming H2S. For example, hydrogen sulfide. Here sulfur is having -2. So this is called sulfide. Phosphide, nitride. Like that we can write. So if the acid is forming with 2 elements only, in that one is forming anion, that anion is called ion. Okay, clear? So for example, one more, if the acid ends with ick sound, for example, sulfuric acid, nitric acid, acetic acid, oxalic acid, every acid is ending with ick sound. So what is the sound? It is ick. Seriously? H2SO4, sulfuric acid, it is ending with ick sound only. Acetic acid, oxalic acid, phosphoric acid, acetic acid, benzoic acid, formic acid, whatever it is. If the acid ends with ick sound, so the anion is ended with ate sound. The anion is ended with ate sound. For example, sulfuric acid. So the anion should be ended with ate sound. So it is called sulfate. Acetic acid, acetate. Oxalic acid, oxalate. Phosphoric acid, phosphate. Chloric acid, chlorate. Benzoic acid, benzoate. Like that the anions are pronounced. Here, if the compound, the acid is with two elements, one is forming anion, so it is ion. The acid ends with ick sound. So what is the anion? It is the anion ends with ate sound. So sulfuric acid is sulfate, acetic acid is acetate, nitric acid is nitrate, phosphoric acid is phosphate, like that. So for example, one more we see H2SO3. So this is having less number of oxygens. So this acid is called us acid. Sulfurous acid, nitrous acid. The acid ends with us sound. The acid ends with us sound. If the acid ends with us sound, the anion ends with ite sound. So what is the anion? It is ite. For example, sulfurous acid, so it is sulfite. Nitrous acid, nitrite. Phosphorus acid, phosphite. Like that we are writing. So here we are getting three type of anions. If it is only one element is forming anion, that anion is ion. If acid is indicating the anion, it is ate ion. If ick acid is ate ion. Like that anions we are formed. So here you see some anions we have. The F minus one, it is fluoride, chloride, bromide, iodide. Like that we are writing. So sulfuric acid is a sulfate, sulfurous acid is a sulfite, nitric acid so nitrate, nitrous acid so it is nitrite, phosphoric acid is phosphate, phosphorus acid so it is phosphite, carbonic acid so it is carbonate, acetic acid, acetate, benzoic acid, oxalic acid, whatever it is. You can easily write the anions. Okay, that is anions. They are from the acids, and second is cations. They are from the base. So generally, the bases, metals, they are forming the bases. So you know very well the metals, the first group elements, and the second group elements, and third group elements. They are the base. They form the base. Why? Because they are having the metal property. First group elements. So that is lithium, sodium, potassium, rubidium, cesium, francium. They are called first group elements. Second group elements, you know very well, beryllium, magnesium, calcium, strontium, barium and radium. Third group elements, boron, aluminium, gallium, indium, thallium, like that. And D black elements, maximum D black, all D black elements are having the metal property. So metal property elements are forming the bases. So for example, the first group elements, except the francium, the remaining elements, they are forming the base. So first group element, so it is lithium, so it is forming only one, it is LiOH. So second it is Na, sodium hydroxide, and potassium hydroxide, and rubidium hydroxide, and cesium hydroxide, like that. The first group elements are with only one OH, second group elements with two OH, BeOH taken twice, MgOH taken twice, CaOH taken twice, and BaOH taken twice. So like that. So SrOH taken twice. So you are forming the second group elements. And the third group elements, they are forming the 3OH aluminum hydroxide, like that you have formed. So first group, second group, and maximum the third group elements, they are forming the bases. From the bases you are getting the cation. So here except OH, the remaining is cation. It is LiOH, the remaining it is OH. So the OH remaining it is Li, and here we have only one OH, so it is plus 1. So similarly the sodium plus 1, potassium plus 1, rubidium plus 1, cesium plus 1. Similarly here we have two OH groups, so plus 2 and plus 2 and plus 2 plus 2 and plus 2. Here we have three OH groups, so it is plus 3. Like that you are forming the cations. And the cations are having the same name only. The lithium itself, it is lithium only. Sodium, potassium, rubidium, cesium, francium. And one more base you have ammonium hydroxide, NH4OH. Ammonium hydroxide, the OH group, the remaining is NH4, and NH4 is having one OH, so it is having one place. That is called ammonium. It is called ammonium cation. So like that, so we are forming the cations and anions. So in the cations, they are from the bases. So the first group elements and second group elements, third group elements, and D black elements. So for example, iron you have, that is iron hydroxide. So here we are forming two type of hydroxides, and zinc hydroxide and copper hydroxide. So nickel hydroxide. So like that you are forming. So here you see the first group elements, second group elements, so maximum third group elements, and D black elements. They are forming the bases. So from the base you are getting the cations. So like that the cations we are introduced and anions we are introduced. So from there, so I am writing the criss-cross formula. So how I am writing the criss-cross formula, now you see. So now only we expanded the criss-cross formula. It is AMBN. So before A and B are the elements. Now A and B are the ions. So A indicating the cation and B indicating the anion. So for example, I am writing one compound, that is calcium carbonate. What is the compound? It is calcium carbonate. So here it is a combination of two words. The one is calcium, second it is carbonate. The calcium indicates the cation and the carbonate indicates the anion. The cation means it is A and carbonate is anion, so it is B. So here the calcium belongs to the second group. So second group, so it is the base calcium hydroxide. So from the second group, what is the cation it is from? Ca plus 2. Why? Because here you have 2 OH minus. So the calcium is getting plus 2 and it is carbonate. 8. The sound indicates the 8. 8 means it is ic acid. Carbonic acid is carbonic acid. Carbonic acid is H2CO3. Except the hydrogen, the remaining is anion. So what is the anion? It is CO3. And how many hydrogens you have? 2. So it is minus. So the A indicates Ca plus 2 and B indicates CO3 minus 2. So again, so it is a crossing the valence is there, but here crossing the charges. That means A is having the cation, so it is having positive charges. How many positive charges? It is indicating the N. How many negative charges? It is indicating the M. So here the calcium is having the cation. So how many positive charges here you have? 2. Similarly, the M indicates the negative charges. So how many negative charges here you have? 2. So I am writing the formula with this one. So A you know, B you know, N and M. So I am crossing. So the A is Ca and B is CO3. And calcium charge is multiplied with B and B charges is multiplied with A. So here Ca2, CO3 taken twice. The both are same 2 and 2 only. So I am cancelling. So what is the one? CaCO3. So what is the formula for calcium carbonate? CaCO3. So like that you can write any compound. So here the criss-cross principle it is extended with anions and cations. The A indicates the cation and B indicates the anion. So A is having a charge. The charge is number of charges is called N, and B is having negative. So it is anion. The number of negative charges is M. So what I am doing, A and B, N and M I am identifying and crossing the charges. So automatically if they are same, just we cross it. So what is the formula you get? CaCO3. Okay, like that the formulas you are getting. And so compound is having some special characteristics. What are the special characteristics we have? So in part 3 we'll discuss. Okay, thank you. And one more thing, please don't forget like, share, comment and subscribe. Don't forget to bell. Thank you.